Cool. For the newcomers, quickly find a seat. We will start now. Nice. Good afternoon, everyone, ladies and gentlemen. Really excited you guys being here, and I'm not super curious why this room be super packed, because this is a extension session for the keynotes this morning from Reno, and also after 10 years of Apache Spark, you guys see a new brand API use English as a new API. It sounds like it quite exciting, even for me as an Apache Spark committer. I also be brand new for this kind of good news. This session will be an extension and also what behind of the cool demo from Allison this morning. So let's go. Put your hands together and let's.
Thank you. Hello, everyone. We are here to introduce the English SDK for Apache Spark. It uses AI to make programming easier and make Apache Spark more user-friendly and accessible than ever before. We are the Spark team at Databricks. I am Gen Liang. I am a PNC member and committer of Apache Spark. My colleague, Alison, is a SQL and Python expert. I believe you already see her amazing video, amazing demo for this project in the keynote this morning. And Amanda is a talent intern. She also contributes important features to the project. Here is the agenda. We will uncover the story behind the English SDK, discuss why it excites us, presenting the awesome features in the SDK, and then share our future plans. As you know, Spark is super popular and powerful. In last year, there is $1 billion from over 200 countries. Although Spark is a robust data process engine, it takes time to master. It's like having a super fast car, but you need to learn how to drive it. Good news is that large language models like GPT-4 are pretty good at understanding Spark. They can use online resources like GitHub, Stack Overflow, to help us smooth out Spark development. For instance, I once asked ChatGPT how to concat two data frames, a popular question for Spark, and the answer was simple and correct. It's a very effective way to get answers for common Spark questions. Besides just using ChatGPT, there are some awesome tools you can use during Spark development. Just check out this GIF. You can see that GitHub Copilot keeps offering code completion suggestions while you type. Many people find it hard to write a SQL function for window operation. And in fact, one of our most popular blog posts in Databricks is about window operation. And with the Copilot, you can write a window function in around 20 seconds. This is more effective than ChatGPT when coding, since you don't have to manually tell AI all the code context. But even with all the cool things it can do, Copilot still requires users to understand the complex code. This can be a problem for new Spark users. Additionally, it cannot be used by notebook, which is loved by data scientists. Furthermore, the suggested code sometimes doesn't seem to understand Spark. When executing the generated code, you will find there is an error about a non-existent column. So even it's a great tool, you will have to have some coding knowledge to use it. I'm a big fan of LangChain, and I help load the Spark SQL agent. LangChain is easy to use. You can ask a question, and it will build a well-tuned prompts with context of your database and data frames. And then it will execute a code and answer the question you ask. It's like having a code executor and reporter combined into one. But when it comes to Spark development, there is some room for improvement. For example, it returns strings instead of Spark objects. So to use the generated code, users have to manually copy and paste it from the output log and then to the code base. Okay, so we have seen that Copilot can work smoothly with code, but it requires technical knowledge. On the other hand, LangChain is easy to use, but the return string cannot be used in the code directly. We start thinking, can we have the best of both? Can we have an easy-to-use tool which seamlessly integrates with Spark? What if we use daily English as code? This is how we started the English SDK. I would like to quote the tweet from Reno. English is the new programming language. Generative AI is the new compiler. And Python is the new bytecode. I will be showing you the key design elements. For the integration, we are making AI the chauffeur, and we take the luxury backseat. Instead of AI as the co-pilot, and we do the driving. The SDK takes English instructions as input and turns them into Spark objects, like DataFrame. In this way, the English code can integrate with Spark APIs. Now, let's see how we implement the window operation using the SDK. You can simply type df.ai.transform, get forward moving average sales by department, and it will return a data frame. Compared to the GitHub Copilot, the code is easy to understand, and you can use the SDK everywhere. Well, the integration is also different from LangChain. With the same input, LangChain will return a string telling you what exactly is the average sales data is. Our SDK also supports cache, which remembers the prompts and the LLM results. This means fewer interaction with large language models and faster executions. Okay. Our SDK is an innovative approach which uses English as code directly instead of generating code. The goal is to make Apache Spark accessible to everyone. Now, let's dive into the exciting part. Alison and Amanda are going to show you the awesome features in the SDK. Over to you, Alison and Amanda.
Thank you, Gengliang. Yeah, so Amanda and I will demonstrate some of the SDK features. But before we dive into the SDK features, I want to re-emphasize that the major difference between English SDK and its alternatives is that English SDK uses English as code instead of generating code. It makes Spark more accessible to a wider audience. Let me show you all these features. The core idea of English SDK for Apache Spark is to provide simple APIs that streamline your development process. It can give SDK and you can give SDK an English description, and it can communicate with large language models to return the desired results. The result can be a data frame, a function, or even a plot. And here are some of the key features we're going to cover today. First, let's talk about data transformations. Since it's the 10th year for Apache Spark, why don't we look at some data from Spark itself? Suppose we have a data frame that contains the historical GitHub pull request data from Spark. For those of you who are not familiar with the pull request, they indicate the community contributions to the source code. Now, let's do some data transformations by computing the 7-day moving average of the daily pull requests created. And here is what I'm going to do. First, we can add a column called date. Then we aggregate the pull requests created by date. And finally, we can compute the 7-day moving average of the pull requests created. Great, let's write the code. I know that we need to use some window functions to compute the moving average, but I can't recall the APIs. Let's search for it. Wait a moment. Instead of looking it up, why don't we just ask ChatGPT? So I copy-pasted my thoughts into ChatGPT, and it generated the code for me. Looks great. Let's try it out. If we directly execute the function from ChatGPT, we get this analysis exception. The error message suggests that a column called pull request cannot be resolved. Let's take a look at the code. Here we see that ChatGPT tries to aggregate a column called pull request, which does not exist in the data frame. This means that we need to provide ChatGPT more information, such as a schema of the data frame. But what exactly does it need? Schema names, column types, nullability? Is the information enough? There's got to be an easier way. Now, forget all the back and forth. Let's see how English SDK can make our life much easier. We can transform a data frame using plain English. It has all the information about the data frame and is able to automatically use the right information when communicating with large language models. Furthermore, it directly returns a data frame instead of code that can be seamlessly used together with the other data frame operations. As we can see, it generates the correct data frame. Another common use case is loading data. Say we want to get all US holidays. I Googled and found this website that contains US holidays. How can I load it to Spark and convert it to the right format? First, I copy-pasted the table content into a spreadsheet, removed extra columns and changed the date format. Then I exported it as a CSV file and saved it to where Spark has access. And finally, I read it in as a CSV file using Spark. This workflow sounds familiar and is acceptable, but it's still too much manual work. Is there an easier way for this? Yes. Using the English SDK, we can provide the URL and the schema names, and it is able to fetch the data correctly. Data looks good. And let's see more examples here. Yeah, let's see another example. Here, I want to get the historical Spark releases from the Spark news page. It is formatted as a list instead of a table. And we cannot just directly copy-paste the data into a spreadsheet. To download the data, we either need to manually type the information or write a web scraper, which is even harder. But now, we can just give the English SDK the URL and schema names, and it's able to create the data frame with the correct version and release dates. Here, we only care about the major and feature releases of Apache Spark, and we can easily transform the data frame using English to filter for the target releases. Now, let's have some fun. What if we want to get the top 10 most popular songs by Taylor Swift? We can just request the data with an English description. Behind the scenes, the SDK performs a web search to get the most relevant information and convert it into a data frame. And we have the data here. Now, let's visualize the data. What if we just want to see a time series of pull requests created over time? We can convert the data frame into a pandas data frame and try to plot it. We get this error, but how should we fix it? So we Googled it and look it up and see the Stack Overflow question. Is there an easier way to do this? The answer is yes. Look how easy it is to create a visualization in English SDK. That's all you need. And here is the result. Great. Now, if we want to overlay the historical Spark releases on the plot, on top of the existing plot, with vertical bars, how should we do it? Everyone who has ever tried to plot something like this knows how painful it can be. And there's got to be an easier way. Now, using the English SDK, we can just ask it to draw this plot for us with a prompt. Show the 7-day moving average and annotate the Spark version with a red line. And the plot looks exactly like what we wanted. OK, to be fair, let's just run it again. Same prompt, and here is another graph. Let's run it one more time. Here's another graph. As we can see, there are slight variations in the plot formatting, but the results are the same. Later on, we will demonstrate how to make this deterministic. OK, why don't we try something more complicated? For instance, show the number of pull requests created by label over time using a stacked bar plot. And here is the prompt. And we can see that this is a graph generated by English SDK. That's pretty accurate, but still, there's a lot of data. How about we just want to take a look at the top 5 labels over the last year? Again, the English SDK is able to comprehend the description and create this pie chart for us. We can see that SQL, Core, Python, Connect, and Build are the top 5 labels. What if we also want to see the distribution of the number of days it takes for a pull request to get merged? We can also easily visualize this information using the English SDK. And here is the plot. As we can see, the majority of the pull requests are reviewed and merged within 5 days. English SDK makes creating visualizations so much easier. Now, let's talk about interpretability. Suppose my colleague wants to understand my logic. I will need to explain the code to her, and she also needs to understand Spark to make sense of it. There's got to be an easier way. With English SDK, why read the code to understand the logic? Code reviews now become much easier with English explanations. For example, here is the explanation for the transformed data frame we just created. It It correctly summarizes the intended logic to aggregate the pull request and compute the 7-day moving average. How about safety? Some of you might think that arbitrary code execution is dangerous. Indeed, we don't like arbitrary code execution, so let's turn on the verbose mode to see how English SDK works under the hood. And here are the logs. It is actually generating SQL queries. Each SQL query corresponds to an English description of the transformation. For example, the first one is to add a new column. Second one is to compute the aggregate the pull request by date. And the third one is to compute the moving average. And now let's talk about reproducibility. We all know that LLM results are usually non-deterministic. How can we make sure that results can be reproduced? To solve this problem, English SDK has a built-in semantic cache to store the generated results for each prompt. We can simply call commit to cache the results for future access. And if we want to regenerate the results, we can simply tell it to not use the cached results. And now, Amanda will talk about data validation and Python UDFs.
Thanks, Allison. So let's talk about data validation now. So how do I ensure the data quality of a data frame? Well, let's say that I want to validate that each date in GitHub DataFrame is a valid date. That's actually a pretty complicated question. I mean, there's a lot of ways that a date can be invalid. So what should my first step be? Well, I'm not sure about you all, but for me, it's always going to be Stack Overflow. Cool, so let's say I search it up and this result pops up. From the title, this looks super promising. Okay, there's code, but look how long it is. I don't really want to read through all this, but I don't know if it's correct, so I probably shouldn't just copy and paste. And look at all these comments. I really don't want to read through all these. I think this comment sums it up pretty well. Writing your own code to validate data can be really, really hard. So what if we just use English SDK to help us with tasks like this? With English SDK, all we have to do is provide a brief description of the expectation that we want to verify. English SDK will then generate code to verify that expectation, run it for us, and output the result, either true or false. All we need to do is provide just a single line of code, which is a whole lot simpler than what we were doing before. So let's look at some more specific examples. So let's validate the data in our 7-day moving average column from GitHub DataFrame. We want to verify that all moving averages are greater than 0. Look how simple this code is. Now let's try running it. And let's turn on verbose mode so that we can see the generated code. And this is what we get. We see the code that has been generated for us. English SDK has also run the code on our data frame, and we see that the result is true. Notice also that even though I didn't tell English SDK the exact schema column name, in the code we see that it's still able to infer the correct moving average column with the name 7-day average. Now let's validate the created at column of our data frame. And let's verify that all PRs were created between the years 2014 and 2023. Here's the code that's generated, and as expected, we get the result true. So remember, in our GitHub data frame, we also had a column with the number of PRs created per day. We expect that there would be at least some outliers in that column. So we'd expect that the result of this verify statement should be false. And great. We run the code, and this is what we get. And notice that the code is using the standard deviation to calculate outliers, and the result is false, which is exactly what we expected. PySpark also has support for Python UDFs. So a UDF is a user-defined function that allows custom logic to be reused. For example, we can apply the same helper function to all data in a data frame. Say that I want a UDF to find the day of the week for a given timestamp, because I want to know what day of the week people tend to close their PRs. Without English SDK, I'd need to define my UDF and write all the code all by myself. Again, probably including a lot of confusing Stack Overflow searching. With English SDK, all that we have to do is provide a user-defined function definition with the expected parameter and return types and a brief docstring description. Now, instead of writing all the code by myself, I can use English SDK to help me. And when I tag my function with the UDF decorator, English SDK will be able to generate code for the function based on the docstring description. Here's the code that English SDK generates when we try running this in a Databricks notebook. And we can easily apply our UDF to a SQL query with a command like this. Here we're calling our new UDF day of week with data from the closed-out column of GitHub DataFrame. And since English SDK returned a callable function for the UDF day of week, all we have to do is register it in Spark, and then it's ready to use. OK, so that was a pretty simple example. Let's look at something a little bit more interesting. I want to see what kinds of pull requests people are making in the Spark repo. This is an actual screenshot of some open PRs in the Spark OSS repo. But there are so many PRs, so I can't just manually label each one, and I also have no idea how to write code that would do this for me. Well, thankfully, since this is a classification task, I know that AI might be able to help me out. Let's try using English SDK to help me use some other AI capabilities. It's AI on AI, if you will. Here's the code that I pass into the English SDK UDF function. And in my docstring, I ask English SDK to use AI to classify PRs as either a feature addition or bug fix based on the PR title. And when I run it, this is the code that I get. And we see that it's using zero-shot classification model to help with our task. And this would be the SQL command to apply the label title UDF to generate a new data frame. And when we run the SQL command, we get a data frame with something like this. All right, so now I'll pass it back to Gengliang to talk about future work.
Thank you. OK. So the English SDK is still in very early stage, and we are excited about its potentials. We will continue working on it, and the future works includes data frame operations with multiple data frames, and we'll try explore the robust text-to-SQL creation, and of course, automatically Python Spark test generation. And when the user-defined Python table functions and data sources are available on Apache Spark, we will work on the AI version. The project is all about making Spark development simple. This way, you can focus more on getting your data insights and spend less time on learning the APIs. Please join our journey and try the English SDK today at pyspark.ai. Thank you.